Good morning everybody, and once again welcome back to the channel. In today's video I want to show you how you guys can schedule your Apache Hudi DeltaStreamer job, interoperate between Hudi and Iceberg using Airflow. So the goal of the video is to show you how to leverage Airflow to schedule your DeltaStreamer jobs on EMR Serverless. So without wasting any further time, let's get started. Alright, so the first step is we need some sample data set to play with, and you can head over to my GitHub page and there will be a link given to you. If you simply click on the link, it would take you to the Google Drive link and download the jar folder and the test folder. The test folder has a Parquet file and the jar folder has some jar files that we would need for the project. So come to AWS S3 or whatever bucket you choose for the demo and simply upload these two folders, jar folder and the test folder. The test folder will have the Parquet file, which is a sample data set, and the jar folder will have these jar files. So go ahead and do this particular step. All right, so now the step 2 is basically we need an EMR serverless cluster, and you can easily go ahead and create one for yourself by heading over to EMR serverless and clicking on this orange button, give it a name, big data, choose a type as Spark, use the version as 7.0, and all the way on the bottom section, click on create application. I already have a cluster, but I wanted to walk you over the steps. So this is my EMR serverless cluster that I'm gonna use. All right, it's time we work with Airflow, right? So to simplify things, and you can do it locally, we're gonna use Astro CLI. You can install by the following command, which is brew install Astro. This will install the CLI command for you. Now, let's get started with the Airflow, right? So Astro dev init, and this will basically initialize a working project directory where you can see you have a DAG folder. Inside the DAG folder, you have two example DAGs given for you. Now, what you need to do is there's an env folder here. Okay, click on the env folder, and then what you need to do is you need to paste these three env variables inside that. Put your AWS access, put your AWS secret, and the region where you're working. I'm doing this lab on US East 1, so make sure you set these variables. Now we will be basically creating a DAG. DAG is nothing but a job which will basically read the data from our S3 test folder, and it will basically create a Hudi transactional data lake. After each particular commit, it will perform translation of the metadata into Iceberg as well. So now we can interoperate between Hudi and Iceberg. So now let's look at the Airflow DAG code. And I have tried my level best to simplify that for you using a template. So let's take a look at that. All right, I'll spend some time on the DAG because I think that's where I need to explain you a little bit. Okay, so in the DAG folder, we're gonna create a new Python file. Name this Python file called DeltaStreamer _bronze _invoices.py. Okay, and in that we will copy paste this particular code that I'm about to explain you. So first of all, paste the code that is given to you, and now let's go over the DAG code, what it's doing. Okay, so let me resize my window quickly. So I have resized my window. Hopefully this made sense. Now the entire Airflow DAG code is controlled through a JSON object, right? And I wanted to make this thing very easy. I don't want to have like complicated DAG structure, etc. So simple JSON object which will parse all the arguments, and then it's gonna submit the job to the EMR serverless cluster, and also it will check the status and print on the console real time after probably every 1 second. All right, so let's take a look at this, the job config, right? So you have a jar. Inside this, you have all the jar files. So we uploaded these jars on S3, right? So these jar you downloaded from the Google Drive link in the step 1, right? Hopefully made sense. So if I quickly go to my S3, in the jar folder, as you can see, we have these jar files, right, that you uploaded over here, right? So for this, we are using the Hudi Java client 0.14 jar, and then we're using Hudi -extension -.1.0 snapshot bundle jar. And then we are using a built-in jar, which is Hudi utility bundle jar. So these are the three jar files. All you gotta do is come here and simply replace your bucket name. Now, in the Spark submit parameters, these are all the configuration related to the Spark conf, right? Those all go inside here. Okay, and then you have the arguments, and this is where you define all the settings, right? So all the Hudi related settings will go inside an entity called Hudi conf. So here, let's review this. Table type is copy on write, method is upsert. Then we are using io.onetable.hoodie.sync.onetable sync tool. This allows us to, create metadata after each particular commit, which means once we are ingesting data from the Parquet source, after every commit, the DeltaStreamer will build the metadata for Iceberg. Okay. Since we are ingesting from Parquet, that's why the class is org.apache.hoodie.utilities.sources Parquet DFS source. Okay. Then over here we define where is our data. Our data is inside this particular bucket, inside the folder test. We already have uploaded this on S3, right? In the step 1 we did that, right? And I gave you the instruction for that, hopefully. So this is the test folder where we have a sample data set, as you can see. And then this is where you would build the Hudi transactional data lake inside a folder called test cases. Okay. Then simple, man, we define the record key, we define the precom key, we define the table name, we define the partition path. And then here we are saying that, hey, build the metadata for Iceberg after every single commit. So if you see, I have simplified the entire, Spark Submit job into a JSON, right? So anything that you want to change, it becomes very easy for you, right? Now let's collapse this, and let's go to the job argument. The job name is DeltaStreamer bronze, DeltaStreamer _bronze _ invoice. So if you are using a silver zone, replace this by silver. This is a good naming convention to follow. Created by who's the owner of the job, who made this job, when was it created, the application ID. So this is the application ID of the EMR serverless cluster. Hopefully I can show you, where is that? Over here. Yeah, this one over here. And then job status polling to true. If you set this to false, what I've done in the code is basically, I'll explain you. So after every 1 second, it will poll for the status to EMR serverless for that particular job, and it's going to print the job status on the console. Okay. And then, yeah, you just provide the ARN, and that's about it. So if you see, this particular JSON, controls the entire code base, right? So anything that you want to change, the developer or he or she doesn't really need to go inside the code base and do. All he or she needs to do is just simply work with the JSON object. That's it, right? And now the code over here, you have a function called create DAG. It creates a DAG, as you can see, and then it will submit the job to the EMR serverless. So as you can see over here, this will submit the job to EMR serverless. It will parse all the configuration for you. If job status polling is set to true, it will print the status on the console, as you can see. If the status is failed, the Airflow job will fail, and probably you'll get an email saying that, hey, this job has failed, right? So hopefully that made sense, right? So it's pretty straightforward. Okay, so come and please do take a look at it. So let me resize my window again. So I'm gonna do that quickly. So I'm gonna pause the video because I need to resize the resolution. Let me see if I can do that. All right, I think that's done. All right, so that's the job. Okay, so now let's close this. Okay, and now we will run the Airflow container. So let's come here, terminal. Now to start the Airflow container, we can use a command called, let me see, I have that in my notes, astro dev start, and this should start my container. Okay, so let's see, astro dev start. Now it's starting the container. So it's gonna take a while, so I'm gonna pause the video right here. So my Airflow container has started, as you can see. Username is admin. So what we can do is now admin. So again, with your example tags here, you will see your DeltaStreamer DAG, which will submit the job to EMR serverless cluster. You can click here, you can click on graph, you can also see the code base here, right? So hopefully made sense. So now what would be amazing is to see things in action. So let's fire this and see whether this job submits a job to EMR serverless, and whether also we see the job status on the log section. So let's see that in action. Alrighty, let's do it. So heading over back to my DAG. Now I'll click on this button trigger DAG, which will fire the job. As you can see over here, I see a green, which means it's trying to run now. So if you click here and go to logs, here I'm able to see that the job has been submitted, and now the job status is currently scheduled. So what I'll do is I want to wait to see, once the job is in the pending state, and of course once it is in the running state, right? So right now the job status is scheduled, and we can see the status over here in the Airflow log section. So let me go to the EMR Serverless and see what's going on. So here I'm gonna simply refresh, and I do see a job in scheduled state, and which is why the status on here is in the scheduled state, right? So what you can see is we are able to see the status in the Airflow DAG is all I'm trying to say. Again, if it fails over here, you will see the failed message, and you can probably invoke an email saying that, hey, the job failed, etc., etc. Okay, now you can see it's been in the running state. We are seeing the status, right? So over here, refresh. Yep, now the job is in the running state, as you can see. So hopefully made sense, right? So now let's wait for the job to complete. The job could take about 5 to 10 minutes roughly. And what we would see is we would see a folder called test cases in our S3, and we will see our Hudi transactional data lake partitioned by state. And also we should see the Iceberg metadata. And again, we can now easily, orchestrate our DeltaStreamer jobs using Airflow, right? So important thing that you wanna keep a note here is the entire job is done through this JSON object. So tomorrow, let's say, hey, you wanna make let's say a silver table, right? So all you come and just change things in the JSON object, right? You don't go and touch the other code, right? You come here, change the JSON object, and boom, done, right? Hopefully made sense. So yeah, let's wait. I think over here, let's go. We still see the status as running because the job is still running, and ooh, look at that. The job is now in the success, right? So the job has succeeded. Now again, in Airflow, you can send emails and this and that, right, if needed. So now let's go to EMR, and hopefully here also the status should be success. Perfect, perfect. Great, great, great. Now if you go to S3 and if we come to refresh, hey, look at that. We got that. Okay, perfect. We got our Hudi table created, and metadata. Yep, there you go. That's the Iceberg metadata. So now this table could be interoperated either as Hudi or Iceberg. Doesn't really matter, right? That's the beauty, right? So you can use Apache Xtable, DeltaStreamer, ingest the data from any sources, which is Parquet, CSV, Kafka, bring them into S3 as a transactional data lake, build the metadata along with when you're ingesting, build the metadata for Iceberg. Then you can either interoperate between any of the lakehouse format. And also now you learn how you can leverage Airflow to probably schedule your EMR serverless job. I'll leave the code in the description. The code is very, very easy, and it's very easy to follow. All you need to do is step 1, upload the sample test folder and the jar folder on S3. Then step 2, you do Astro CLI, you init the project. Once you init the project, you copy paste the code, change the variable names, and then you just run the job. That's it. So I hope you enjoyed. With that being said, if you have any further questions, please let me know, and I'll be more than happy to answer those questions. Thank you so much for watching, and I will be seeing you in the next video.